I've been in the United States for the last 16 years. I was initially at the University of Colorado, and then subsequently I went to the University of Michigan. And most recently, in July of this year, I've returned to Monash University. Current manufacturing of plastics, of polymers, is capital expensive. So buying molds, buying injection molders, that sort of thing, there's a lot that goes into that. If you can simply purchase a 3D printer and make a variety of different items, it's a completely different paradigm. We're hoping to impact the transportation sector, so within automotive, aerospace, marine and rail. Our research involves dramatically increasing fabrication rates in polymeric and composite materials.
So he's got this new ultra-rapid method of 3D printing which has real commercial potential.
3D printing currently, for the most part, it's used for rapid prototyping. So that has sort of just general utility, but it's small scale. If you want to use additive manufacturing, 3D printing, in actual production, then you need to have much faster production rates. The biggest benefit is being able to make low to moderate volume parts quickly and inexpensively.
The space that Tim works in, additive manufacturing, is of great technological importance, and Tim's got some new technology for doing more rapid additive manufacturing, more efficient, more economical. So this has the potential to create economic benefits, investment, create jobs in Victoria.
Our particular approach is it's a stereolithographic additive manufacturing approach. So that means that we're using light to solidify liquid resin. So you start with a liquid, you irradiate that liquid using visible or UV light, and it becomes solid. By using different materials, more advanced materials, it hugely increases the opportunities to apply this sort of technology to different industrial sectors. If you have a material that's able to survive for a long time, then for a start, it really reduces the amount of waste. So polymers tend to degrade, they become embrittled under consistent UV exposure. We're specifically trying to address that. The ultimate goal of our research from an industrial perspective is to launch a startup company which will commercialise the technology.
The support of veski and the Victorian government has been really key, because it makes our offering to Tim more attractive. It makes it easier for us to bring in really impressive academics.
We're working towards sort of developing skills in the workforce in an industrially relevant class of materials, and we're also developing intellectual property in these classes of materials. So hopefully, in the fullness of time, that will be translated to industry.
Students will have the opportunity to work with somebody who's really at the cutting edge of technology in the 3D printing space.
The students are going to get pretty intensive training in areas that are certainly industrially relevant, both in the biosciences and also in general material science.
He's already making an impact in this space scientifically through high-quality publications, but also for us it develops new technologies that we can commercialise and develop some economic benefit from, and also boost the reputation of the department and the university at the same time.
There were several things that attracted me. It was a great opportunity to have a real impact on a university that I care a lot about, but also the facilities that are here, both on-site and also across the road at the synchrotron and the MCN. I'm working on developing collaborations with people who are examining computation in material science, and also people who are working on more bio-related aspects to material science. And I'll also be working with people here at Monash University, some individuals at the University of Melbourne, and some folks at Deakin. In 2 to 5 years' time, hopefully we'll have actually commercialised our current research and be on to the second or third generation.